This video is relatively long, over 4 minutes, but it's packed with useful information. My goal is to clearly explain the situations where different materials can share the same tool. At SDF Tools, we frequently test tools in real-world scenarios. We don't just blindly follow rules, we rely on practical testing. If you want to learn, make sure to watch the entire video. And if you could give it a thumbs up, I'd really appreciate it. Thank you. We often see letters like P, M, K, N, S, H on tool packaging boxes with different colors. These aren't just for decoration, they are standard identifiers for different material categories. I won't read them out loud since everyone can recognize the letters. Just refer to the image. Currently, these materials each have their own dedicated tools. In large-scale production by big factories, they tend to use specialized tools with very detailed matching. However, this video isn't about big factories. They have enough budget to use whatever they want. For small and medium-sized enterprises, or SMEs, considering both machining costs and volume, we might use one tool for 2 or 3 types of materials. So, which materials and tools can be paired together? First, let's categorize by material. Category 1. Materials like carbon steel, alloy steel, cast steel, and ductile iron can generally share the same tool. Currently, drills, milling tools, or turning tools mainly use carbide or ceramic tools. But taps are an exception. High-speed steel taps, also known as HSS taps, are still preferred. Category 2. Stainless steel materials. Let's break this down further. For easier-to-machine stainless steels, such as 303 and 304, we recommend using dedicated stainless steel tools. For example, tools with unequal indexing and unequal pitch designs work well. If you're a small shop doing small batch processing and don't want to buy dedicated stainless steel tools, you can substitute with tools from Category 1, which are designed for steel materials. However, for large-scale production, it's best to use dedicated stainless steel tools since there are specific drills, mills, and turning tools designed for stainless steel. Category 3. Difficult-to-machine stainless steels and high-temperature alloys, such as 316, 317, duplex stainless steel, Hastelloy, titanium alloys, and nickel-based superalloys, can share the same tool. Of course, nickel-based superalloys are particularly challenging to machine and wear tools faster, so custom tools are highly recommended. Important note: tools for this category can also process materials in Category 2, such as 303 and 304, and can be shared. Category 4. Non-ferrous metals, such as aluminum and copper. Dedicated aluminum tools are ideal here. They are usually designed to be very sharp and made from carbide or polycrystalline diamond tools, also known as PCD tools. However, casting aluminum alloys, such as ADC12, are an exception because of their high silicon content, which makes them more abrasive. For these, tools designed for difficult-to-machine materials, or Category 3, can be used. Category 5. High-hardness materials, typically heat-treated to a hardness of around 45 HRC or even 50+ HRC. These materials require special attention and are best machined with high-quality ultra-fine grain carbide tools or cubic boron nitride tools, also known as CBN tools. Special reminder: the coating on these tools is crucial for their performance. Finally, a word about grey cast iron. This material is relatively easy to machine. Grey iron contains many impurities, and its rust state differs from other material sets powdery. Both high-speed steel tools and carbide tools can handle grey iron. However, when selecting taps, make sure to choose straight flute taps. That's all for today's sharing. If you have any questions, leave me a comment below.